Hello, Honors Algebra 1. It is Tuesday, April 21st, and we are on our last section of Chapter 11. It's been a long chapter. Tomorrow is Wednesday. We will have a quiz tomorrow, and then I think we'll go ahead and we'll do our chapter review tomorrow and our quiz, and we'll take our test on Thursday since it's open book, and I'll get those quizzes graded for you tomorrow evening, and you can look those over before you take the test on Thursday, so we can just end this chapter this week. Okay, so our last section is called Simple Radical Equations. Radical equations. So now we're going to take a radical and put it inside an equation and solve for the variable. Now we call it a radical equation not just because it has a radical term, but because the variable that we're solving for is part of the radicand. So our goal here first is to isolate the radical term. So in order to do that in this first example, I'm going to subtract 2 from both sides. So I'm going to end up with the square root of 5x plus 1 equals 4. Now, I've isolated my radical. Well, what is the opposite of taking a square root? It is squaring. And so what we're going to do is the inverse of square root. We're going to square both sides of our equation in order to get this variable out from under the root. So I'm going to square the left side and square the right side. But when I square a square root, I end up just getting rid of the radical, and I have the radicand 5x plus 1 is equal to 16. Now, this is just a simple equation to solve, isn't it? I'm going to subtract 1 from both sides. 5x equals 15, x equals 3. And I'm going to box it. Now, let me tell you something very, very important about solving a radical equation, and that is this. You always need to check for extraneous solutions. Extraneous solutions. So what that means is when you square both sides of an equation, sometimes you come up with solutions that really do not work, that do not make the equation true. And that's what an extraneous solution is. It's one that does not work. And so I'm going to go ahead and look at 3, since I've had to square both sides, and I'm going to plug it into the original equation and see if my equation is true. So if I plug in 3 here, I get 15 plus 1. I get the square root of 16 is 4, and 4 plus 2 is 6. 4 plus 2 is 6. So that one works. We can keep it boxed. I usually don't box them until I check them, but this one works. So we're good. We don't have to unbox it. Now, let's try this one. This one is a little bit more complicated. Now, on this one, we have a radicand that has an x squared term, but we're going to do the same thing we did before. We're going to isolate the radical term. So to isolate the radical term, I'm going to leave the radical here on the left side, and I'm going to set it equal to 2x. Now, what do I do to eliminate the radical? I'm going to square both sides. So let's go ahead and square this. I'm going to put this in parentheses and also square it. Let's see what happens. So I'm going to have 11x squared minus 63 equals 4x squared. Okay, now let's keep going. Let's bring all the square terms to the left and the 63 to the other side. All right, so 11x squared minus 4x squared is going to be 7x squared is equal to 63. What am I going to do to both sides of my equation? I'm going to divide by 7. And so x squared equals what? X squared equals 9. Now, to solve, I'm going to take the square root of the left side gives me x. Now, some of you missed this on the quiz. How many solutions are there here? 2. X can equal positive or negative 3. Now, let's go ahead and plug both of these in and see if both answers work in the original equation. So over here, I have 11 times 3 squared. I might need my calculator here. Go ahead and get my calculator out. Okay. So I've got 11 times 3 squared. So I've got the square root of 99 minus 63 minus 2. Remember, I'm using my positive 3 equals 0. Let's see if that's true. So I'm going to go ahead. 99 minus 63 is 36. So I've got the square root of 36 minus 6 equals 0. Well, is that true? Of course it is. 6 minus 6 equals 0. Check. Positive 3 is a solution. Now let's try negative 3. So with negative 3, I'm still going to have the square root. Negative 3 squared is still 9. So 9 times 11, I still get 99 minus 63 for my radicand minus 2. Now I'm going to plug in negative 3 here. I'm going to plug in negative 3 and equals 0. And so we already knew that this is the square root of 36 minus, plus 6 equals 0. Does 6 plus 6 equal 0? No, it does not. And so, I'm sorry about that glare, guys. That is bad news glare. Hold on. I'm doing this late afternoon. Okay. So, what do I know? Negative 3 is not a solution. And so I come down to the side here and I box x equals positive 3 only. I had an extraneous solution of negative 3. So anytime you square both sides of your equation, you're going to have to check your answers. Always check them when you square both sides. Okay, well that's it. You have a few of these for practice tonight. You have a few, I think 3 problems to do, word problems to do that have to do with a radical equation, setting that up and solving it. And then you have mixed review, which I cut in half, and your self-test. So I know that seems like a lot, but there's not a lot of practice problems from this set. So anyway, so that's it for today. And tomorrow we'll take our quiz and work on our chapter review test on Thursday. Okay, well, I hope y'all have a blessed Tuesday, and I will talk to you soon. I'll see you at Zoom if you need me. Bye-bye.